so now we're going to get into chapter 4. And in chapter 4, we'll be looking at the type of chemical reaction that takes place in aqueous solutions. All right. So before we get into the actual reactions, we need to talk about the electrical properties of aqueous solutions. Now, solutions can contain two types of charges, all right? Positive and negative charges. And this is as a result of the presence of particular ions that may exist in these solutions. And we talked about ions already, and we talked about ionic compounds. So you're going to see some ionic compounds involved in some of what we're going to discuss today. Let me go to full screen here. So this picture here, this diagram here, basically shows you the behavior of particles that are charged. And understanding this will help to understand certain things that we're going to discuss shortly. So this is purely hypothetical, of course. So let's say we have two particles here that are neutral, no charge, right? And they're hanging from this support right here. Well, because these are not charged, there'll be no attractive or repulsive forces between them due to any charges because no charges exist. So they remain stationary without influencing each other. In the case of this situation where we have a plus charge and a minus charge on the separate particles right here, there'll be an attractive force between them because the charges are opposite. All right. And this is basically how charges behave. Opposite charges will attract each other. And then the last two shows you what happens when the charges are the same. Light charges, as in the case of this situation where we have two plus charges or two negative charges, will repel each other. All right. So that's basically what happens in these cases. All right. So that's basically what I just described here is basically a description of the nature of these charges. And they're very similar to how simple bar magnets behave, right? If you have ever played with bar magnets, you realize that basically each magnet has a north and a south pole. And if you have two bar magnets and you try to put two like poles in close proximity to each other, they will repel. But if you put the negative, or I should say the north, close to the positive or the south pole, I'm sorry, then basically they'll attract each other. So it's a very similar behavior that is displayed by charges. All right. Now, one particular property of ionic compounds is that in certain situations, they can conduct electric currents, right? Now, let me just briefly describe what happens when a current is passing through anything, a circuit, whatever, wires, solutions, whatever. Basically, an electric current is said to occur when you have charges moving through a certain medium, all right? Now, the normal electric current that we are familiar with, result in us having, lamps and so on, is the result of electrons flowing through wires. All right. So the current is basically in those situations is produced when you have electrons flowing through wires. Now, when it comes to ionic compounds, if the compound is in a molten state, which basically means that it is in a liquid state, right? Molten is a term that is used for compounds that normally exist as solids under normal room temperature conditions, but in order for it to be melted, you'd have to heat it to a very high temperature. So we say that these ionic compounds are said to be molten when in a liquid state. Or if the ionic compound is in an aqueous solution, then these situations, the ionic compounds in these states would be very good conductors of electricity. And the reason why is because one, they are made up of charges, namely cations, which are positively charged, and anions, which are negatively charged. And the other reason why the compound in these states is a very good conductor of electricity is because in the molten state and in an aqueous solution, the ions are free to move around. All right, they're mobile. All right, they're not static or stationary as they are in the solid state. So what will happen if you set up an experiment like this, where you have an electricity source? So this could be a series of batteries, or cells, I should say, to make up a battery, and you have wires connected to the electricity source to metals, which serves as an anode and cathode, and you dip it into a solution or a molten form of the ionic compound. And what will happen if you, well, there should be a switch here, but if you flip the switch to turn on the circuit or open up the circuit, then basically you're going to have an electric current passing through. And one could put as a part of the circuit a device for measuring the current and so on, which is not shown here. But in any case, an electric current will pass through. Now, the electric current through the external wires will be due to electrons flowing through. But within the molten or ionic solution inside the vessel right here, with the current flowing through here will be due to the charges that are mobile. Now, in the case of this electrode, which is the anode, which is positively charged, it will attract the anions or the negatively charged ions. That's why the negatively charged ions are called anions, because they are attracted to the anode, while the positively charged ions will be attracted to the negatively charged electrode, which would be the cathode, right? So anions are attracted to the anode. The positive ions, cations, are attracted to the cathode, right? So that is basically one important property that you need to be aware of when it comes to ionic compounds. In the molten state or in the aqueous state, they will conduct electricity, but they will not conduct electricity in the solid state, all right? So that's the relationship between the ions that are present in these compounds and their ability to conduct electricity. Okay, let's see what we have here. So this is just saying some stuff I said before. The anode is positively charged, the cathode is negatively charged, and the anions are attracted to the anode, the cations are attracted to the cathode. Okay, so now that we have covered that, now we can talk about the different types of solutions with respect to their ability to conduct electricity. So basically, there are three categories. You have solutions of what we call non-electrolytes. Non-electrolytes are compounds which, when dissolved in water, does not conduct electricity because in the aqueous solution, they exist exclusively as intact molecules. So there's no dissociation. They do not break up to form ions. All right. A good example of this would be a 1 molar solution of ethanol. As you can see here, ethanol has no, it's not ionic, right? So therefore it will not dissociate. And therefore, if you try to conduct electricity through it, if you set up an experiment, such as the one that you see here, to see if it will conduct electricity, you'll see that there's no electricity that is passing through the solution. And that is indicated in this particular setup by the fact that this lamp right here, this bulb, is not lit at all, right? So therefore, basically, what is not shown here actually is the external electricity source, right? But you can imagine the electricity source being connected to both the lamp and the arrangement here where the solution has two electrodes dipped in it. In this particular setup, there is no electric current passing through because the light or the lamp is not lit. Now, in the case of electrolytes, there are two types, right? So an electrolyte is basically a compound which, when dissolved in water, produces an electric current. And there are two types of electrolytes. You have strong electrolytes and weak electrolytes. Now, in the case of strong electrolytes, the resulting solutions are very good conductors of electricity, and that is illustrated in this picture right here. In this case, we're talking about a 1 molar solution of sodium chloride, which is a very strong electrolyte. In fact, if you could see the particles in this solution, you'll see mostly ions and water molecules, of course, but mostly ions. And as a result, these ions are very mobile and therefore will conduct electricity if connected to an external electricity source, and that is indicated by this bulb being brightly lit. All right. Now that is different from weak electrolytes, which will undergo partial ionization or dissociation, and therefore they are poor conductors of electricity. So when we talk about partial dissociation or ionization, what we're saying is that only a small fraction of the molecules will be converted to ions. So therefore, if you could see the particles present in a solution, you would see mostly intact molecules of the acetic acid and very few ions, right? So that's what's being illustrated here. And in this particular setup, the light or the lamp or the bulb does light up, but not as brightly as in the case of the strong electrolytes. So this shows you experimentally the difference between a strong and a weak electrolyte. Okay, so those are the different categories. So the next video, I'm going to stop here. The next video, we're going to look more at some quantitative aspects of solutions. All right? Okay, until next time.